So in this section, section 6.6, we're just going to apply what we've learned with exponentials and logarithmic functions. So we're going to be doing compound interest. We're also going to do carbon dating. And last but not least, something that's been in the news, bacteria, the growth of bacteria. So let's start with our compound interest. You've already seen these formulas before, the PERT formula, or as Miss Roberts says, the clean formula, and then the dirty formula. So it just depends on how it's compounded. So we're going to use those formulas that we've already talked about before. So the first thing I'm going to do is read the problem and write down what I know. Find the present value of an account that will be worth $25,000 in 2.75 years if the interest is compounded quarterly at 6%. So we know that we want to find the present value. That's the P, the principal. Okay, so that is what we don't know. We know that it's going to be worth $25,000. So that is my future amount. And the time is 2.75 years. And remember, time's always in years. So if they give it to you in months, you have to change it. The interest is compounded quarterly. So since it's compounded quarterly, we know we're going to be using that compound interest formula rather than the continuous one. So quarterly means 4 times a year, and my rate is 6%, and I'm going to write it as a decimal. So now we just have to plug it into that formula. It's a little bit different than what we've done in the previous sections, because in the previous sections we were solving for the A. Now we know the A, so the A is $25,000. What we don't know is our P. So we're going to put all our information in based on that formula right there. So that's how we plug it in. Now notice that we are now, we've got to get P all by itself. So there's my P. So basically I need to divide by all of this. So I'm going to just divide by that, 0.064. We're going to do that on both sides. So the trick here is getting it into your calculator correctly, okay? So my P, I should have just wrote that out, it's 25,000, and we're going to divide it by this. So now we've got to plug that in our calculator. So when you plug it in your calculator, this is how it's going to look. You're going to have $25,000, big parentheses, and then you're going to have, whoops, I should put division in there, sorry, with the division sign, and then big parentheses, and then you're going to have to do another parentheses because I've got to put that 1.06, I'll write it out long ways, 0.06 divided by 4, okay, and you've got to raise that to the 4 times 2.75, and then close your parentheses. So that is, that's the difficult part, is putting that into your calculator. So you'll just need to practice that. So my principal should be, and we're just going to round it to normal money decimal places. So I needed to start off with $21,223.33 to have $25,000 later on. Okay. Okay, so let's try another one. Again, the hardest part of that is just putting that into your calculator. So now they want to estimate how long it will take 5,000 to grow to 8,400 at a rate of 6% if it's compounded these two different ways. So we've got semi-annually and continuously. Well, for all of these, I know that I'm going to start off with 5,000. I also know that I want my final amount to be, 8,400. My time is what I don't know, okay? And my interest rate is 6%. So now I'm going to use that to plug into the first one, semi-annually. So semi-annually means we're going to have an N of 2. It's going to compound twice that year. So here's my formula. I'm going to go ahead and write it down for you again. All right, and now we're just going to plug in what we know. So we've got 8,400, and we start off with 5,000. 1 plus, we know our rate, we know our n, and so it's going to be n times the t. The t is what we don't know. Okay, so I am going to go ahead and simplify this a little bit, okay? So first thing I did is I'm going to simplify that part right there. So I plugged that into my calculator, and I just got 1.02 to the 2t. Now, it might start looking somewhat familiar. Notice that I've got this t up here, so I'm going to eventually be having to take the log or natural log of both sides to get that t in the front, but it's not by itself yet. So let's go ahead and divide by 5,000. So we have the log of what, 80, whoops, not log, but we have, let me move it up a little bit. So I'm just going to simplify it a little bit, but I'm not going to go all the way down to a decimal just because sometimes that messes things up. I'm not really sure why, but sometimes it messes it up. Okay, so now I've got to get that 2t down front, right? So I'm going to take the log of both sides, log, or you can say ln, doesn't really matter. So what that allows me to do is bring that 2t in front. So now I'm going to have, let's come over here. So I've got log of 84 over 50 equals 2t times the log of 1.02 because I brought it down in front. Okay, so now again we need to get this t by itself, so all we're going to do is divide by 2 times the log of 1.02. 2 times the log of 1.02. So once again, the difficulty is plugging this into my calculator. Okay, so to plug that in, you're going to put in log, I'll just stick it up here for right now, log, and I'm going to put of 84 divided by 50, divided by, and then I'm going to put a big parentheses, 2 times the log of 1.02. And once you put that in your calculator, you should get a time of about 8.775 years. Okay? So now, let's see, let me see if I can move that. So now we're going to, I'll move that over down here somewhere. All right, so now we're going to do the continuous. So now we're just using a different formula, our PERT formula. So we've got 8,400, and we've got our 5,000, e to the r, and the r was 6%, and my t. So this one's a little bit easier. I'm going to go ahead and I'm going to divide by my 5,000. So I got 1.68, and that's going to give me e to the 0.06t. All right, so now I need to get this thing down in front, right? So since I have an e there, I'm going to take the natural log. Okay, so that means I'm going to have the natural log of 1.68, and this is going to go down in the front, 0.06t times the natural log of e. Oh, wait a minute, sorry. Actually, it's even easier than that, because when we take the natural log of e, remember that's log base e, so that just disappears. So really that is just 0.06t. It's much easier. And then I just divide by 0.06. So I just plug that in my calculator. So I should get that that's going to be 8.6466 years. Alrighty. So let's do one more. Estimate the interest rate necessary for the present value, $1,200, to grow to a future value of $1,408 if the interest is compounded quarterly for 8 years. All right, so since it says quarterly, that means we're going to deal with the n again. Okay, so my n is going to be 4. Notice it gave me the present value of 1,200. So that's my present, 1200. I want to get 1408. Okay. And the time is 8 years. And we don't know the rate because that's what they're asking us for. Okay. So let's go ahead and grab my formula, and I'm going to put in what I know. Okay. So 1408, 1200. My rate again was what I don't know, over 4. And I've got an R up there too. Let's see. No, the N is 4. So 4 times 8 years. All right. So let's figure this out. Okay, so we've got to get R by itself. So notice R is inside. Okay, here's my R. So I need to get to it eventually. So first thing I can do is get rid of this 1200, right? So I'm going to divide by 1200. I'm going to leave that. Sometimes when you actually work it out, it messes it up, I have found. So I have 1 plus R to the 4th raised to the 32nd power. All right. So here we're going to get a little fun. We need to get rid of my 32nd power. Now remember, if I had something to the second, remember how I get rid of that? Take the square root of both sides. So we are going to take the 32nd root. I know that's crazy, but we're going to take the 32nd root. And when we do that, this is what we're going to wind up with. The 32nd root of that is going to be equal to my 1 plus R over 4. Okay, so now I'm going to move that 1, 32nd power. I'm going to subtract 1 from it. Gives me R over 4. My last step, multiply everything by 4. So the last part is you just have to plug this in the calculator. So you're going to plug this whole thing into your calculator. And you could do 4 times 32nd power. And remember, that's under math. And you'll have something like that. And you'll put the 32nd power in there. 1408, 1200. Okay. And then we're going to subtract. I'm going to subtract 4 because I'm just distributing that. All right. So plug that in your calculator. And you should get something. It's like 0.02 something. So that's going to give you 2%. So I'm going to stop the video now and let you work on that a little bit, and then we'll come back and do carbon dating and bacteria.